Hello everyone, this is the challenge question walkthrough for Edexcel's Applied Year 1 textbook, and this is the first part of the mechanics section from chapters 8 to 9. Okay, our first question is from exercise 9b. The graph shows the velocity of an object travelling in a straight line during a 10-second time interval. Part A says after how long did the object change direction. Part B says work out the total distance travelled by the object. And part C says work out the displacement from the starting point of the object after 6 seconds and 10 seconds. Okay, so first of all, for part A, after how long did the object change direction? So we know that for velocity, the sign determines whether it's travelling in one direction or the opposite direction. So we can see that the velocity becomes negative after 6 seconds. So our answer is 6 seconds. Part B says work out the total distance travelled by the object. So the distance is a scalar quantity, so we count going forwards and backwards as distance. So we need to find out this area here and add it to this area here, and that will give us the distance, the total distance. So for this first area here, this is a trapezium and it has a height of 3. This top length is 1 and this bottom length is 6. So using the formula for the area of a trapezium, we have this area 1 is equal to the top and bottom lengths, so 1 plus 6 over 2 multiplied by the height, so that's 3, and that will give us 21 over 2. So that is meters. And for the second area here, this is another trapezium. So its length here is 2. That's 10 to the 8. This length here is 4. And this length here, the height is 2. So using the same formula, we have 2 plus 4 over 2 times 2, and that gives us 6 meters. So the total distance travelled will be 21 over 2 plus 6, which is equal to 33 over 2 meters. And for part C, work out the displacement from the starting point of the object after 6 seconds and then 10 seconds. So for 0 to 6 seconds, we know that it travels 21 meters in the positive direction. So for part I, this will just be 21 over 2 meters. And for part 2, we know that the particle has travelled backwards 6 meters. So its total displacement from the starting point will be 21 over 2 minus 6. Because what the particle has done is it's gone 21 over 2 meters to the right. And then it's changed, the velocity has changed sign, so it's moving backwards. And it's gone back 6 meters. So its total displacement after 10 seconds will be 21 over 2 minus 6, which is 9 over 2 meters. And that is our final answer. Okay, our next question is from exercise 9c. A particle moves in a straight line from A to B with constant acceleration. The particle moves from A with velocity 3 meters per second, and it reaches point B with velocity 5 meters per second t seconds later. 1 second after the first particle leaves point A second particle also starts to move in a straight line from A to B with constant acceleration. Its velocity at point A is 4 meters per second, and it reaches point B with velocity 8 meters per second at the same time as the first particle. And we're asked to find, for part A, the value of t, and for part B, the distance between A and B. Okay, so if we draw a little diagram to help with this, so we have here, if this is the point A, and this is the point B, then the particle moves along this line here, and it starts at point A with velocity 3 meters per second, and it reaches point B with velocity 5 meters per second, and this takes time t seconds. And 1 second after the first particle leaves point A second particle also starts to move in a straight line from A to B with constant acceleration. and this particle, I'll do this in red, this particle's velocity at A is 4 meters per second, and it reaches point B with velocity 8 meters per second at the same time as the first particle. And because it starts 1 second later, we know that this must take t minus 1 seconds in total. So if we call this distance between A and B d, then we can use this information along with suvat to form two simultaneous equations in d and t. So doing that for the first particle, if we write out suvat, okay, so we know that it has travelled d meters in total, so that's s. We know that the initial velocity is 3, the final velocity is 5, and the time taken is t. So here we can use the equation s equals a half u plus v t to get that d is equal to a half 3 plus 5 t, or 4t. So that is our first equation, d equals 4t. And doing the same for the red particle, writing out suvat. So the distance is d, the initial velocity is 4, final velocity 8, the acceleration we don't know, and t is equal to t minus 1. Okay, so we can use the same formula, so that's s equals a half u plus v t, and plugging in values again, we get d is equal to a half 4 plus 8 times t minus 1, and that gives us 6t minus 6, and that is our second equation. So we can set these two equal to each other, so solving these two simultaneously, we have 4t equals 6t minus 6 because they both equal d, so we get 2t is equal to 6, and therefore t is equal to 3, and that is our answer for part A. For part B, we're asked to find the distance, so that's just d. So d is equal to 4t, so 4 times 3, and that is 12 meters. And those are our final answers. Okay, our next question is from exercise 9e, question 1. Particle P is projected vertically upwards from point O with speed 12 meters per second. 1 second after P has been projected from O, another particle Q is projected vertically upwards from O with speed 20 meters per second. And we're asked to find, for part A, the time between the instant that P is projected from O and the instant when P and Q collide, and for part B, the distance of the point where P and Q collide from O. Okay, so we can draw a quick sketch to see what we've got going on here. So we have a particle P, I'll draw that in blue. This is our particle P. That is projected vertically upwards with speed 12 meters per second. And then 1 second later we have Q, which I'll draw in red. We'll do that on another diagram here. So this is our particle Q, and this is being projected vertically upwards with speed 20 meters per second. Okay, so doing suvat first, if we focus on P. So if we resolve upwards, we have S, U, V, A, and T. So we know that the initial velocity is 12, and the acceleration is minus g due to gravity. And we're interested in the displacement of P from the point O, and also the time it takes. And if we do the same for Q, resolving upwards again, S, U, V, A, and T. So U here is 20, and the acceleration is minus g again. And we're trying to look at distances and time. Okay, if we call the time that they collide t, then we know that the time for P will be t, so that's when they collide. But because Q is projected upwards a second later, we can say that the time taken for Q to collide is t minus 1. So if we find the value of S for P, so SP is equal to UT plus a half at squared. So that is equal to 12t minus g over 2t squared. And doing the same for q, so sq is equal to a ut minus a half, so plus a half at squared. That is equal to 20t minus 20 minus g over 2t minus 1 squared. And if we expand the brackets, we have 20t minus 20 minus g over t squared. We have a minus 2t, so that would give us plus gt, and plus 1, so that's minus g over 2. And collecting like terms here, we have 20 plus gt minus 20 plus g over 2, and finally minus g over 2t squared. And now we're looking at the point where they collide. So when they collide, SP will be equal to SQ. And therefore we can form a quadratic in T. So we have that 12t minus g over 2t squared is equal to 20 plus gt minus 20 plus g over 2 minus g over 2t squared. And we can see here that the minus g over 2t squared will cancel on both sides, and so we're left with a linear equation in t. And if we take the 12t onto the other side, we have 8 plus gt, and taking the 20 plus the minus 20 plus g over 2 to the other side, we have 20 plus g over 2 here. And so we have that t is equal to 20 plus g over 2 over 8 plus g. And using g equals 9.8 and plugging that into your calculator, you should get that t is equal to 1.4 seconds to 2 significant figures. And to finish off, we can use either of SP and SQ because they're equal to substitute t in for. So I'm just going to choose SP because that is simpler to work with. So SP is equal to 12 times the t minus g over 2 t squared, when we're using t is equal to that 1.4, using the answer button on your calculator. So we've got 12 times answer minus 9.8 over 2 times your answer squared. And that will give you 7.2 meters to 2 significant figures. And that is for part B. And this here was part A. Okay, and our second question from exercise 9E. A stone is dropped from the top of a building and 2 seconds later another stone is thrown vertically downwards at a speed of 25 meters per second. Both stones reach the ground at the same time. Find the height of the building. Okay, so again, if we draw a diagram, so this is our building here. And we can call the height of this building h meters. So we have a stone which is dropped from the top of a building. So I'll draw that in blue, and let's call this one A. And we have another stone which is thrown downwards, and we can call this one B. And this is thrown downwards with a speed of 25 meters per second. And A starts from rest. So if we start with A and we resolve downwards using SUVAT, well, we know that the acceleration is equal to g, and we know that it has to fall a height of h, and the initial velocity is 0 because it starts from rest, and the time taken we can call that t. And doing the same for b, resolving downwards, we have that s is equal to h again. We have that the initial velocity is 25 now, and we have the acceleration is g again. And we know that b is thrown 2 seconds later, so we'll have 2 less seconds to move to the bottom, so the time is t minus 2. Now, using the equation s equals ut plus a half at squared, we can use that for both of these stones. So for the stone A, we have that h is equal to ut, which is 0, plus a half at squared, so half gt squared. Doing the same for b, we have h is equal to ut, so 25t minus 2, plus a half gt squared, so t minus 2 squared. And we can expand here, so we have 25t minus 50 plus a half t squared. Then we'll have minus 4t, so that's minus 2gt, and then plus 4, so plus 2g. And collecting like terms here, we get h is equal to half gt squared. We have the 25 minus 2gt and plus 2g minus 50. Now we have a pair of simultaneous equations in h and t. And like for the previous example, we can set them equal to each other because they're both equal to h. So doing that, we get a half gt squared is equal to a half gt squared again, plus 25 minus 2gt plus 2g minus 50. And you can see here that the half gt squareds will cancel again. And so we're left with 25 minus 2gt is equal to 50 minus 2g. Swapping the signs around there. And so we get t is equal to 50 minus 2g over 25 minus 2g. Putting that into a calculator with g equals 9.8, we get 5.62962. And rounding that to two significant figures, we have 5.6 seconds. And substituting this back into our first equation here, we have that h is equal to a half g times 5.6 squared. And this gives us, using the answer button on our calculator, 155.294, so on. And this is 160 meters to two significant figures. Okay, and our final question is for mixed exercise 9. A ball is projected vertically upwards with speed 10 meters per second from a point x, which is 50 meters above the ground. T seconds after the first ball is projected upwards, a second ball is dropped from x. Initially, the second ball is at rest, and the balls collide 25 meters above the ground. Find the value of t. Okay, so if we draw a quick diagram. So this is our ball. And we know that initially it is 50 meters above the ground. So this length here is 50. Okay, and it is projected vertically upwards with speed 10 meters per second. And this is x here. T seconds after the first ball is projected upwards, a second ball is dropped from x. Okay, so we'll draw this in red. And this is dropped from x, so its initial velocity is 0. It starts from rest. And they collide 25 meters above the ground. So when this ball here reaches 25 meters, so down here, we know that the black ball will also be here. So the red ball will travel from x down to this point here, 25 meters above the ground, and the black ball will have to travel upwards and then fall back downwards to that point there. So if we look at the first ball first, if we resolve downwards, writing out Suvat, so we've moved 25 meters downwards. Our initial velocity is minus 10 because we're going upwards. The final velocity we don't know. The acceleration will be g. And we are trying to find the time taken. And we have three of the variables, so we can do this using the equation s equals ut plus a half at squared. So we have 25 is equal to minus 10t plus a half gt squared. And putting this into your calculator, so the coefficient of x squared here is a half g, so 4.9. The coefficient of x is minus 10, and the constant term is minus 25. Putting that into your calculator, you should get two answers. First is t equals 3.498 ... And our second one is t equals minus 1.458, and so on and so on and so on. And we can reject this negative answer. And so we know that the time taken for P to complete its full journey is 3.498 seconds. Now if we look at the second ball in red, so resolving downwards again, SUVAT. So the distance it has travelled downwards is 25 again. The initial velocity is 0, the acceleration is g, and again we're trying to find the time. So using the same equation as up there, s equals ut plus a half at squared. Therefore we get 25 is equal to 0t, so just 0, plus a half at squared. Therefore we get t is equal to the square root of 50 over g. And putting that into your calculator, the square root of 50 over 9.8, we get 2.2587 ... So we know that the second ball was dropped t seconds after the first ball. So we know that the difference in these two times will be our capital T. So capital T is equal to 3.498 ... minus 2.2587 ... And if we put this into our calculator, we will see that we get 1.2 seconds to two significant figures. And that is our final answer. And that is the end of the first part of Edexcel's Applied Year 1 textbook for mechanics.